projects. In this video, we are going to explain about project titled Lung Cancer Detection. The introduction of this project is to employ ensemble algorithm and leverage the CT scan image analysis to enhance the lung cancer detection. By integrating the multiple machine learning technique, the project aims to accurately predict the stage of lung cancer and identify the abnormal CT scan image. The objective of this project is to create an ensemble algorithm by combining the AdaBoost multi-layer perceptron and decision tree algorithms using the lung cancer dataset. The ensemble algorithm will be trained to predict the stage of lung cancer and categorizing it as high, low and medium. Furthermore, a separate RBF algorithm will be trained using the CT scan images to classify them as normal and abnormal, and also a separate 3D CNN algorithm also trained using the CT scan images to classify them as normal and abnormal. These are the basic requirements that are needed to build this project. Hardware requirements: operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk 20 GB and above. Software requirement: Python IDE with version of 3.7. These are the modules that are developed to build this project. The first module is upload the lung cancer dataset. In this module, the lung cancer dataset containing the relevant information and features related to the lung cancer cases will be uploaded to the application. And the second module is dataset pre-processing. Before training the algorithm, the lung cancer dataset will undergo the pre-processing. This step involves cleaning the data, handling the missing value, and performing the necessary transformation to ensure the data is in a suitable format for training. And the third module is run ensemble algorithm. In this module, the ensemble algorithm is combining of AdaBoost multi-layer perceptron and decision tree will be trained on the pre-processed lung cancer dataset. The algorithm will learn patterns and relationships in the data to predict the stage of lung cancer as of high, low or medium. And the fourth module is of predict the lung cancer disease. Once the ensemble algorithm is trained, the application will allow the user to upload the test data such as patient information and relevant features. The algorithm will then predict the stage of lung cancer for the given test data. And the fifth module is train the RBF on lung CT scan image. In this module, the RBF algorithm, that is radial basis function algorithm, will be trained using the lung cancer CT scan images. The algorithm will learn to classify these images as normal or abnormal based on the patterns and features it captured during the training. And the sixth module is run 3D CNN on the CT scan dataset. In this module, the 3D convolution neural network algorithm will be applied to the CT scan dataset. The CT scan dataset consisting of three-dimensional images that capture the multiple slices of the lungs. The 3D CNN algorithm will be trained on this dataset to learn the features and patterns that are indicative of the lung cancer. By leveraging the depth and spatial information in the CT scan images, the 3D CNN algorithm aims to accurately classify the lung cancer cases. The seventh module is of accuracy graph. After training the CNN algorithm on the CT scan dataset and by using the RBF algorithm, the accuracy graph will be generated. This graph will provide a visual representation of the algorithm performance in terms of accuracy. It will help access the algorithm ability to correctly classify the lung cancer cases based on the CT scan images. And the final module is predict the cancer from CT scan. After training the algorithms, the application will enable the user to upload the CT scan image for prediction. The algorithm will analyze the uploaded image and predict whether it is normal or abnormal, potentially indicating the presence of lung cancer. The execution of the project. For execution, first we need to open the code folder. This is the code folder consisting of different files. The dataset folder consisting of the dataset and the test dataset, and the lung images dataset consisting of normal and abnormal images of the images. And this is the model folder consisting of .hy files. Here, these .hy file contain the algorithm information. This hy file can loaded into the project code during the runtime to utilize the trained model for various tasks, such as making the prediction on new data or performing the specific operation. And the test images folder consisting of different images which is used for testing the model. And the lung cancer detection test and test train are the Python code files, and these two are of the images, and this is the run.bat file. Here this is used instead of executing the program in command line interface. We created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. Here, this is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Lung Cancer Dataset. By this, we are going to import the dataset from this folder, and then selecting the dataset from this dataset folder and click on Open button. Here, we get a graph where the x-axis represents of the high, low and medium stages of lung cancer, and the y-axis represents the count of high, count of low and count of medium the lung cancer from the lung cancer dataset, and then close this graph. Here the total dataset contains of 1000 records and total attributes of 25, and then click on dataset pre-processing button to change the non-numeric form data into new numeric format. And here the data is formatted to the numeric format and consisting of 5 rows and 25 columns with total number of records of 1000 and total features are of 23, and then click on Run Ensemble Algorithm button. By this, the algorithm is generated with the pre-processed data set by using the decision tree MLP and AdaBoost. Here, it gives the accuracy of 100%, precision of 100%, recall of 100% and F measure 200%. And then click on Predict the Lung Cancer Disease button. By this, it is redirected to the dataset folder, and we need to select the test from this dataset folder and then click on Open button. Here, the data present between the square bracket is of the test data, and the predicted disease status as low, CT scan is not required, and here for this it is detected as medium, for this it is predicted as of high. In this way, we can predict the lung cancer without using the CT scan image, and then click on Train RBF on the lung CT scan images button. By this, we need to select the lung image dataset and then click on Select Folder button. By this, the RBF SVM gives the accuracy of 92.85% by training on the pre-processed dataset of CT scan images, and then click on Run 3D CNN on CT scan dataset. Here, the 3D CNN algorithm model is generated by using the CT scan images and gives an accuracy of 92.85, F measure of 92.85, recall of 92.85 and precision of 92.85, and then click on Accuracy Graph button. By this, bar graph of accuracy comparison graph. Here, the x-axis represents the algorithms we used in this project, and the y-axis represents of the accuracy and the value assigned for the each algorithm we used in this project, and then close this graph. Click on Predict Cancer from CT Scan Image button. Here it is redirected to the test images, and We need to select any one of the image from this test images folder, and I am selecting of the 6th image and then click on open button. Here it is detected as normal. In this way we can upload and verify with the other CT scan images too. And this way we can detect the lung cancer using these algorithms. The conclusion of the project is the implementation of the ensemble algorithms and CT scan images analysis. This project has demonstrated the promising result in the yield of the lung cancer detection. By accurately predicting the cancer stage and identifying the abnormal CT scan images, we have taken significant steps towards improving the diagnosis and potentially saving life. Further research and development in this area can lead to the enhanced early detection and treatment outcomes for lung cancer patients.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.